Determine the following operations for these sets. U is the universe, and it is the numbers 1 through 10. A is the numbers 1 through 5. B is the numbers 2, 4, 6, and 8. And C is the numbers 1, 3, 5, 7, and 9. And I'm thinking about these three sets. And I want to draw a Venn diagram. So I have choices with three sets. I can draw all three of them intersecting. And that means that they have something in common here between all three sets, that there's a number or numbers that are in all three sets. Or it could be that I have two sets share some elements, and one of those shares elements with a third set. That would look something like that. Or I could have two elements, or two sets share elements, but the third set doesn't have any elements in common. Or I could have some combinations like that. And so I'm looking at these sets trying to figure out where do we fit. And I see the first set has a 1 in it, and I see a 1 in set C. So I know A and C at least have one element in common. And then when I take a look at B, I see it starts with a 2, and set A has a 2 as well. So I'm putting a different symbol for it. So I can see that A has elements in common with B, A has elements in common with C, and then I want to look and see, do I use this picture or this picture? Because right now I could use either one. But what I have to figure out is, do B and C have elements in common? 2, 4, 6, 8. There's no 2, no 4, no 6, no 8. They don't. So I want to use something like this set notation. So I'm going to put it in here and try to make it a little bit bigger. I hope you don't mind my ugly circles. So I have a universe, and then I have to figure out which of these balls should be called A, B, and C. And A was the one that had something in common with the other two. B and C had nothing in common. So I should label the ones on either end B and C, and the one in the middle that had something in common with each of the other sets should be called A, and it's in the middle. Then I want to start labeling. So I know that set A has the numbers 1, 2, 3, 4, 5. B has 2, 4, 6, 8. So I know 2 was in common. And then I see that I also have 4 in common between sets A and B. So between A and B, in the intersection part, I can write the number 2 and the number 4. Then I'm looking at set C. I see it has 1, 3, 5, 7, 9. And I come back to A, 1, oh, there's a 3 and a 5. And that takes care of those elements. So 1, 3, and 5 are in common between A and C. So 1, 3, and 5. Now it looks like every element in set A has been taken care of and is shown in the intersections actually between A and the other two sets. And that's okay. That means there's nothing here in this common part, or this A part alone, that does not also belong to one of the other sets. B has 2 and 4 written in the intersection, but it also has 6 and 8, and 6 and 8 do not appear in any other set, so I put them just in the B part alone. And finally, set C has 7 and 9, and that does not appear in any of the other sets, so 7 and 9 go in the C proper. And then I have to come back to the universe and check it. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here, if I look, I have 1, 2, 3, 4, 5. There's 6, 7, 8, 9. The only thing missing is the 10. I can add that to the universe, not in any one of the particular sets. Once I have my Venn diagram drawn, then I can start talking about set operations such as number 1, A union B. Remember, union takes everything from both sets, including the intersection. So I'm talking about everything here. Everything in A no matter if it's shared with another set or not, and everything in B. I would like them written in numerical order just because it's easier for me to find that you put everything in there. But it would start with 1, and then I see 2, 3, 4, 5, and then I see 6, but no 7. So I won't even write it, and I'll put 8 last and end the squiggly. So if you look back at your sets, the sets in the Venn diagram, you can see that I got everything that was in A or B. B union C. So B and C don't have anything in common, but a union is saying take everything that's in either set and list it out. So everything in B, everything in A. And again, we'd like to do it in numerical order. So starting with 1, 2, 3, 4, 5, 6, 7, 8, 9. And that is all the numbers 1 through 9. But no 10, remember, because that was outside of both of the sets. A intersect C. So the intersection is the part that's in the middle in common, and A intersect C is going to be 1, 3, and 5. Not A means you're looking at set A and you want to take the complement. So look at set A and forget about it. Cover it up with your thumb or whatever you need to do and find all the other numbers that are not in set A. So to do that, we have 1, 2, 3, 4, 5 that are all in set A, and everything else will be 6, 7, 8, 9, and 10 because it is not in set A. So 10 has to go in there as well. B intersect C. So I'm looking at B and looking at C, and I want to know what's in common between those two. And we've been talking over and over, they have no intersection. So my answer is going to be the empty set in one of its two forms. You can choose. My last one is A union B. So I'm looking here, A union B is all of these numbers, and I want the complement of that. So the ones that are not being marked up by my highlighter right now. And I can see that is going to be 7, 9, and 10. Those are outside the A and B balls together. So that's going to be the set 7, 9, and 10.